Hi, this is Dr. Caney. We're going to look at the combined effects of having two motions in the solar system. One motion we've talked about in the notes already is the daily spin of the Earth, of course. Once a day the Earth spins on an axis. For the purpose of this demo, we'll let the white ball here be the Earth. For observers on the Earth, which we'll think of as being here at this X, we spin once a day. From our vantage point, though, that just means the rest of the universe seems to be spinning and turning around us. On top of that, though, there's also the yearly motion of the Earth around the Sun. And then for the Sun, we have the yellow ball right here. So we go around the Sun once a year as we're constantly spinning and turning. So we have a combined combination of these two motions together. That gives you some more complicated effects. One effect of that is that the stars and the sun don't exactly track across the sky at the same rate, the same speed. The stars cross the sky about 4 minutes faster each day. If you imagined a line drawn across the sky from north to south, when the sun crosses that line each day, it would be 24 hours later before it came around and crossed that line again. Whereas the stars, when a star crosses that imaginary line, it's just 23 hours and 56 minutes before it comes back all the way around. So the stars are constantly getting 4 minutes farther ahead each day, which is enough over the course of a year that they end up basically making one complete extra loop around the sky. So there's one more sidereal day, or star passage, than there is solar days, which is the sun going by in the sky. Where that one extra comes from is actually not too hard to show, to illustrate, and that's the purpose here. I'm going to rotate the Earth and move it around the sun, and we're going to count days. We're going to count solar days and then count sidereal days. Every time the X is kind of pointed at the sun, that'll be one solar day. And then you have a role to play in this as well. You're the distant stars way out there somewhere. Every time the X is facing you, that'll be one sidereal day. Okay, so I'll start here, make one loop around. Now, for the actual solar system, of course, the Earth is spinning a lot faster than it goes around. It makes 365, roughly, spins in just one revolution around the sun. So that's a lot of spins to count, keep track of. But fortunately, we don't have to go that hardcore. The effect of having one extra rotation works even if there's a lot fewer days per year. So I'm going to essentially slow the Earth way down here. I'm just going to turn the Earth 4 times as we go around the sun once. So kind of 4 solar days. But as we go along, we'll count solar days and count sidereal days and see what happens. So starting here, both the sun and the stars are overhead. So this will be solar day 0, sidereal day 0. And as we come around, sidereal day 1, solar day 1, sidereal day 2, solar day 2, sidereal day 3, solar day 3, sidereal day 4, and finally back to where we started, solar day 4, but also sidereal day 5. So 4 solar days, 5 sidereal days. Do it one more time quickly just to see how that works. Again, starting here, solar day 0, star day or sidereal day 0, star day 1, solar day 1, star day 2, solar day 2, star day 3, solar day 3, star day 4, and then solar day 4 and star day 5 both come in at the very end. One feature of this, it does make a difference on the sense of the two rotations. In our actual solar system, if you were to go kind of north of the solar system and look back down from above, most motions, both of these included, are counterclockwise. So I've been turning this counterclockwise as seen from above, and I've also been going around the sun in a counterclockwise fashion. And again, the difference in the two counts between the solar days and sidereal days just being one isn't affected by how many actual days there are in a year, which isn't really too hard to see. Isn't hard to understand. If I were just to hold the Earth in one place and spin it, say I spun it 5 times, then there wouldn't be any difference. So the sun would go by 5 times, and the stars would also go by 5 times. But then if you add on top of that motion right there, that essentially kind of unwinds or cancels out, undoes one of the solar passages. So the number of solar days ends up being one less than the number of times you actually turned, which was the number of sidereal days.